Welcome back to a new video lesson on microeconomics. In previous videos, we have introduced some basics of game theory, such as the definition of a game or the elements required to consider a strategic game that were players, strategies, and payoffs. In this new video, we will complete the introduction to game theory by discussing how a game can be represented. There are two main ways to represent a strategic situation, or one in which the final outcomes of the agents involved are interdependent. Firstly, the so-called normal way, and secondly, the extensive way. Let us begin with the normal way, also known as the matrix or strategic way, depending on the textbook we consult. This normal way is used in strategic games when decisions are made, or in a simultaneous way, or when they are made sequentially but the individuals don't know the decisions previously made by others. If the game involves only two players, one or two, we can represent information of the strategic or normal way with a payoff matrix. In this matrix, one of the players will be placed in the columns and the other one in the rows. Each column corresponds to a different strategy profile for any player, and each cell, therefore, corresponds to a vector of strategies. And in each cell, we will indicate the utility or economic benefit that each player could obtain if they behave according to the strategy profile corresponding to that cell. Let's look at the following example to better understand this way of representing or graphing a static game. Suppose we have two players, Javier, in the rows and Andres in columns. Javier has three possible strategies or choices to make: U, M, or D, up, middle, or down, while Andres has only two strategies, L or R, left or right. In each of the 6 cells of the matrix, we show the final payoffs that Javier, the first number in each cell, and Andres, the second one, would obtain if they choose the strategies corresponding to that row and column respectively. For example, if Javier plays up U and Andres plays right R, they would obtain respectively 2 and 3 utils, or units of the corresponding payoff. The same logic applies to the other cells of the matrix. The extensive way, on the other hand, is used in dynamic games, where sequential decisions are made, or in games where there are situations of imperfect or asymmetric information. It's also called the tree way, because it's represented through decision trees or game trees. In each node of the tree, a player is represented, while the branches correspond to the strategies of each player, and the final payoff is shown at the end of each branch, on the leaves of the tree, or in the terminal nodes of the tree. As in the case of the matrix, the first number of the payoff corresponds always to the first player, and so on. Let's look at the following example to better understand this extensive way of representation of any game. Suppose we have a sequential game where players make decisions not simultaneously but consecutively. Javier decides first and has two possible strategies or alternatives, A and B. If he plays A, the game ends. If he plays B, Then is Andres' turn. This player has three possible strategies: C, D, or E. If he plays D, the game ends. But if he plays C or E, then it's Jose's turn. Jose has only two likely strategies, F or G, and whichever he chooses, the game ends. At the end of each branch that leads to the end of the game, we find the payoffs for each of the three players. For example, if Javier plays A and the game ends, he earns 0, while Andres and Jose earn 1 and 2 respectively. If Javier plays B, then Andres chooses E, and finally Jose plays G, the final payoffs for each of them will be 3, 1, and 2. This way of representation is very useful when we want to predict the solutions of dynamic or repeated games, as we can separate the nodes and treat them as independent games. It's also helpful in cases of incomplete information for some players, as we can indicate this by placing a cloud over that player, a notation that is visually clearer than if the game were represented using a matrix, which also becomes less valid when there are more than two players.